Hi there. The wireless technology that has unquestionably experienced the most buzz in recent years is 5G and LTE. Cisco is working with mining companies to deliver an as-a-service model into mine sites that provides central administration for simplicity, but local operation for survivability. Here's Derick to explain how that all works.
So again, guys, thanks for the opportunity to spend about 50 minutes talking about Cisco's private 5G as a service offering. I understand that in the last summit that we actually had, Roland, keep me honest here, that was about a year ago. We've already discussed some of the initial thinking behind what Cisco has done, or what Cisco was planning to do in the private LTE and the private 5G space. And what I'm glad to say is that we've actually launched this as a solution from Cisco that is now consumable to our partners. And if you can tell, I'm actually trapped in an RF cage, which I'm doing a lot of radio testing with our solution with one of our soon-to-be certified partners here in Canada, so that we can add to the list of certified partners that can deliver a private 5G or a private LTE solution or combination of both for customers and entities that are joined on this call. So without further ado, it is interesting because ever since we've actually physically launched this solution in the July timeframe of 2022, we've had a lot of people come knocking on the door to say, hey, this is interesting. This would be quite exciting for my existing use case, my existing deployment scenario, my requirements. And we've been tracking them very closely from 9 months in, 8 months, 9 months in. We're about 400 plus real opportunities where Cisco has been actively engaging with our partners for these particular enterprise customers. And they span the world where we actually have the ability to secure spectrum, private spectrum, be able to launch this particular solution. And of course, for the most part, this is quite successful in the United States because the CBRS band, which was liberalized by the FCC, is a unique way whereby enterprise customers like yourself could obtain sizable chunk of private LTE and private 5G spectrum for a nominal cost, rather than the traditional model, which is what you typically see in Canada and other countries, whereby you actually have to go to the regulators and pay them a lot of money to be able to gain access to a small chunk of spectrum. Now it is changing a bit. For example, in Canada, with ISET's recent policy changes that are coming up in 2027, we're hoping that the market will open up a little bit, and that they allow for a much more liberalized access for enterprise customers like yourself to be able to enjoy getting private spectrum to go forward with. But as I said, like you can tell, I'm in an RF cage. We're doing lots of proof of concept and lab testing, and we're doing lots of field trials, and we actually have a couple of systems already in production with a number of customers, so they're quite happy with what the solution tries going forward. The idea here is, of course, that in order to make this an efficient and deliverable solution that an enterprise customer could potentially consume, we need to span the globe and offer an end-to-end offering, which includes more than just the Cisco components that we traditionally bring to the table. Because you need to think about, in addition to the packet core, which is what one part of the whole private LTE, private 5G, or private wireless network services entails, you also have to think about the radio infrastructure, the radios themselves, what type of radios, which are non-Cisco components, and what the infrastructure that ties these radios back to the packet core would look like, which could be a Cisco-based solution. It could be something else if it's an existing infrastructure that we wanted to be able to drop our radios into. But there's more than that. Unlike a more liberal approach that most people have taken with when it comes to a Wi-Fi based deployment, you really have to think about engineering and planning of this infrastructure, because one of the key tenets of a private wireless or private wireless infrastructure or private wireless network services is that we can now offer deterministic radio behavior and deterministic coverage and capacity capabilities for the devices that connect into it. And that's the fundamental building block whereby we as in the industry can say private wireless networking is really aimed at the mission critical / OT style networking requirement that a lot of enterprise customers, including the miners, would require going forward. And when you think about,
Hey, Derick.
Go ahead. Yeah, go ahead.
Yeah, no, Derick, I was just curious. For some reason, your video stopped coming through shortly after you started sharing. I'm not sure if that's something that you did on your end or.
No, I'm actually presenting videos. Okay. But as long as the slides go through, that's all I care.
Yeah, we're good. We got your audio nice and clear, and the slides are coming through nice and clear. So I'm gonna not interrupt you here again for a bit. Thanks a lot.
No worries. Yeah. Besides, what would you want to care looking at our RF gauge anyway? So it's kind of boring. Unless you want to look at it. Unless you want to look at my test gear, but that's a different thing. So what I'm trying to say is that we need to, as an offer, think about more than just hardware, more than just radios, more than just plopping down switches and routers to be able to interconnect these radios in a mine, for example. We also have to think about how we design and implement this at the most efficient and cost-optimized way so we can deliver on the promise of a deterministic radio access layer. I can actually hang my hat on how much bandwidth, how much delay, how much throughput I'm going to expect at any point in the mine itself, and what that looks like as the mine matures, as the mine changes its geographical nature, if it's an underground mine versus a surface mine going forward. So that whole engineering aspect is a big piece of this private wireless networking services that Cisco is hoping to wrap into the private 5G as a service offering, using our partners that are competent and have the skill set to be able to deliver that going forward. But it doesn't stop there. As was mentioned before by the previous speakers, we need to actually be very much in the ecosystem of the end devices that would actually enjoy these types of services. So if we're talking about Caterpillar systems, or we're talking about Komatsu systems, or we're talking about any type of industrial mining-oriented systems, end devices that need to be integrated into this private wireless networking services, there are certain nuances we have to be careful with. What bands are they operating on? What is the power level it looks like for these devices? Do they have the capabilities and the feature sets based on the standards that the private wireless networking guys are actually pushing out to be able to enjoy ultra reliable, low latency control for that matter, or any other 3GPP oriented features and functionality rather than, oh, it just connects. So we're looking for really an advanced, competent, optimized solution that spans the whole chain of command in terms of the packet core, in terms of the access infrastructure that you have to lay down, in terms of the radio infrastructure that you have to lay down, where they have to be laid down, how they have to lay down, what the radio systems, antennas look like, how do they point into the mine itself, what spectrum you're going to use. And we all know from experience that if you're mining potash, for example, versus mining cobalt or mining copper, there is going to be differences in terms of how the radio infrastructure would react based on the minerals that's in the ground. So we have to be careful and confident there in terms of the engineering that happens associated with that. All with the aim at delivering a deterministic and competent solution that's optimized for the mining operations that a particular enterprise customer is interested in. Having said that, and I'm sure you've seen this in the previous summit that was held, we took a hybrid-based approach when it comes to delivering private wireless networking services for our customers. So there is stuff that's happening in the hybrid cloud, which is a combination of public cloud services as well as private cloud services that Cisco brings to deal with all the complexities of bringing up a private LTE or private 5G infrastructure from a management standpoint, all the backend systems, all the OS systems that you have to buy to make a private wireless infrastructure useful. So we did that. We actually managed and operate that on your behalf. And of course, any customer that signs up with this particular service will have access to that infrastructure and be able to realize the benefits of that. But I'm no longer going to ask a mine operator to say, hey, you need to learn 3GPP because you need to learn what an SDM is, you need to learn what a mobility management layer is, you need to learn all this other stuff that you normally would not be exposed to before in the past. So the onboarding process, the actual consumption of the service, we want to make it as simple as possible. Having said that, we also realize that this is a mission critical network that we're building. So the actual infrastructure can't be in the cloud. We can't just dump the packet core in the cloud and then expect our customers to connect into that, because you're going to run into all sorts of problems when it comes to security integration, when it comes to policy integration, when it comes to access integration and whatnot. So our approach is saying, no, put the packet core, one per customer, in the customer's infrastructure and domain itself, so that the customer, the mine operator itself, has direct access to the equipment. The equipment sits in their IP infrastructure. It inherits their IP infrastructure. It inherits the security profile settings. It inherits the policy and authentication process that a mining operation would entail. Thereby, I can solve a ton of problems when it comes to simple things like, how do I do handover between a licensed radio technology like 4G and 5G to Wi-Fi? Because I may already have Wi-Fi at the mine. I want to augment that. I want to introduce some resiliency. I want to introduce some redundancy. I want to introduce some capability where the automated hauler that's coming out of the mine with ore can actually hand off the Wi-Fi, because that particular section of the mine is better suited for a Wi-Fi based deployment. Those types of problems is what Cisco is hyper focused on solving and providing an optimized architecture and strategy going forward. We do want to offer our customers the choice in terms of the radio capabilities, because I see a lot of quote unquote religion when it comes to selection of the radio manufacturers themselves. Cisco wants to stay neutral, and we would like to say to our mining friends that, hey, you pick the radio that makes the most sense for the type of mine that you're actually running, and you will see that certain radio systems, whether it's indoor or outdoor, in certain bands that you may be able to get, will operate better than other radio systems in other bands that they operate in. So there's still some customization and some choices that we need to make in terms of the environmental and the specifics of the mine operation itself that goes forward. There also may be certain certification that certain autonomous systems may require. Caterpillar, Komatsu, all the other heavy equipment manufacturers have pretty much done a very good job of providing an ecosystem of solutions when it comes to the actual device that needs to connect to a licensed radio infrastructure. And they may prefer, and they may tell you, hey, I need you to run on this vendor XYZ radio system that needs to interconnect into this radio infrastructure. We think that's great. We need to be able to support that going forward. So there should be no religion, there should be no choices that can't be made because of the choice of the radio system that is involved in that. Obviously, Cisco is going to promote the ones that we actually done validation and certification for, and we'll obviously add more radio systems and partners to this picture. Currently, we are actually focused on Airspan and JMA as the two main radio manufacturers currently for the solution, but you will see other radio manufacturers join the list, so to speak, and it's hence why I'm in this RF gauge. If the video is actually working, but you can actually see that. So I mentioned partners, and what I mean by that is that we will not sell a private wireless networking service directly to enterprise customers because of that, because we truly believe that the engineering aspect, the understanding of how to deal with the third-party radio systems and how to do support for mission critical based networks is key and central for a successful operation going forward. And hence why we insist, more or less, that this solution is delivered to Cisco certified partners that actually have this competence, the skill set, the know-how, and the engineering expertise and background to be able to deploy in these specific use cases, such as mining. And in Canada, we have very good partners that are currently very much focused on the mining sector and actually making lots of inroads with a number of opportunities in the mining sector that actually we're hoping to leverage across the market, so that any other mining operator that's interested in being able to consume this from Cisco would be able to do that through our certified partners. The solution is driven, and go ahead.
Hey, Derick. Just on that point, maybe it's worth noting that that there are specific, like mine specific partners that we have that actually have certifications to walk into mine sites and do wireless assessments and figure out what spectrum's being used and all of that stuff. Help with
Exactly.
spectrum.
Yeah.
Yeah, all of those things, right? So even if our primary partner doesn't necessarily have that expertise in a particular geo, we would partner with mine-specific partners that would help us to move into those specific areas. I don't know, maybe I stole your thunder there, but I just wanted to make sure that connection was made.
Yeah, absolutely right, Roland. And even a little bit further, we have mine-specific partners to deal with mine-specific requirements when it comes to insurance, when it comes to certifications to be able to get into the mine, be able to assist miners, because a lot of miners would like to do a lot of the physical engine deployment of the equipment, the electrical themselves, because they have the necessary skill sets already on site. So we do more of a consultative approach to be able to associate, to be able to get these mining operations bootstrapped, but also still interesting things such as the ability to be able to obtain spectrum from ISET. Our mine-specific partners have the experience of how to do that, and they can actually leverage that experience to be able to accelerate the ability to create a true private wireless networking service at a mine-specific site. Because we've done that before, we know the exact process that needs to be taken in. So the right to operate a spectrum is an interesting one, and depending on what type of mine you type, you may have a view as to, yeah, I need to go the ISET route, or no, I'm underground 3 kilometers, who cares? It's not going to leak out. Those types of things are interesting discussions that our partner can certainly have a discussion on and be able to consult and guide in terms of what the most appropriate approach would be. So what I wanted to do for the rest of the discussion is to focus on a key aspect of the private 5G solution that we think is key and central and sort of differentiates from other private wireless networking services that you may see from our competitors in this particular space as well. And that is the aspect of how we approach policy and authorization of a private wireless device in your mine. And you may say, well, who cares? Just connect and then life is good. Unfortunately, the licensed radio world has a completely different view in terms of how devices are supposed to connect and how devices are supposed to be instantiated when it comes to policy and its associated authorization. And they typically don't jive with the traditional enterprise IT-oriented approach that we're all come to love for the last 10 years. So if you have any type of Wi-Fi based deployment or curb-based deployments today that is enjoying an IT-based authentication, authorization, and possibly an accounting-based process, having the traditional 3GPP-oriented private wireless networking services from another vendor come into play, you're going to have to treat that infrastructure as a foreign network, which, from a security standpoint, wait a minute, that's a foreign network. That's a different IP address range. Maybe I'm going to have to apply, it's an outside access. How do I get my device that's on the outside into my infrastructure itself? And this is still a requirement that would force the security people in the room to get quite nervous and focus on VPN style access and policy assessment and policy posture-based monitoring and control of those particular connections itself, which it makes it very difficult then to think about how you would actually transition from a licensed radio-based access to a Wi-Fi access and vice versa, because they're in the different domains. So what Cisco has done is try to address this head on by saying, no, what we want to do is integrate and merge these two authentication, authorization, and policy systems into one, whereby you as the enterprise, you as the miner, IT person in the mining site, control that, not an external entity that provides that connectivity for you. And it's part of our larger mission. It is part of our mission to be able to scale up the solution that we launched in June of last year. So when we launched in June of last year, we really focused on, let's do some edge automation, which is, how do we onboard a brand new private wireless networking service at a particular mine site? It should be fairly simple and straightforward. There should be minimal, specialization that's required on site to be able to stand up this particular infrastructure. And so the onboarding process has to be very simple and straightforward, almost, dare I say, plug and play. And of course, like if you're familiar with the Meraki solution, we need to be able to provide you as the IT person in the mining site, the ability to be able to manage this particular infrastructure using some sort of dashboard. Now, what is the site doing? How much bandwidth is the site consuming and producing? What are the individual devices doing? Where are those individual devices and where are they connected to? And maybe I should bring one offline because it's going to a maintenance shack and it needs to be brought offline. So those types of day-to-day operations should be fairly simple and straightforward. I should not, as a vendor, come to you and say, oh, that's a 3GPP specification, that's an N8 interface that you need to be messing around with the specific attributes associated with that. That's all gobbledygook that, yes, it's great for a person like myself because I'm highly interested in that, but for most operations-oriented people, that's not necessarily what we need to focus on. We need to focus on the outcomes, not necessarily the nuanced technical details behind the scenes. So the second part that we focus on, which was happening in the October timeframe, was we introduced more scalable options, as well as the initial phase of this unified policy and identity integration using the Cisco ICE server. We also introduced security integration. So if you have an implementation in your existing mining operations from an IT standpoint that uses the Cisco umbrella framework, we now allow that particular umbrella framework and its associated mechanisms and capabilities to be extended in the private wireless networking arena. And then the last one that got delivered this February is the high availability option to bolster this whole mission critical notion for private wireless networking. You know, you cannot call yourself a mission critical infrastructure if the infrastructure has a single point of failure. So we've actually constructed an approach whereby for operations where it has to be 24/7, you can never take it down, you can never suffer a single point of failure. If a server blows up, the service has to be hitless. We came up with an architecture and an approach that allows for us to deploy this private wireless networking service in a high availability capability model. And then last but not least, for those people that are cool and interested and wants to know how to gain access to all the underlying capabilities of this particular solutions, we have now made available all the APIs that opens up the monitoring and the configuration of this particular interface infrastructure for you available as well. And as I see going into the future, we are actually starting to think about the idea that we're offering a portal where you can actually manage this private wireless networking for yourself. Might be cool, but there may be customers, miners like yourself, that already have a DNAC-based deployment. And maybe they want to consume all those sets of services capabilities using the DNAC environment rather than going to a portal and be able to get your information there. Or Meraki, the Meraki dashboard for that particular set. All that needs to be taken care of as part of our control center integration, our CC integration as it's listed there. But that's the aim that we're going to, is that the distinction of the different portals, different systems for management becomes blurred. And you as the customer can decide, no, I want to consume this through DNAC, or I want to consume this through the Meraki dashboard, or I want to stick with the original approach that Cisco has going forward. Obviously, the Wi-Fi offload associated with public and private roaming are two key concepts that we're also thinking about in terms of how we actually push private wireless access outside of the mining operation, outside the geographical domain of the mine itself. How do you get service? How do I fall back onto a public operator for that matter, so that I can still track that vehicle or the autonomous haulage, or not on a road, but you can still track that asset on a public-based infrastructure where you don't have necessarily private wireless services going forward. And then the unified telemetry platform is an idea that we think a lot of people will enjoy because they've already deployed 1,000 eyes from a stock visibility standpoint that we want to be able to integrate with. And lastly, for standards and compliance reasons, a lot of the US-based entities as well as miners are asking for FedRAMP-based compliance that we're adding to as well. So, as I said before, when we launched in June of 2022, we came up with an architecture that allows for an optimized edge to be deployed in your infrastructure that can scale, that can support both 4G and 5G at the same time. So we don't ask to do any forklift upgrades if you decide to go from 4G to 5G, or if a particular device is only 4G capable, we can support both at the same time, or one or the other. It's totally up to you. It is completely automated so that we can actually drive the cost down of installing and onboarding customers, as well as monitoring the configurations. And because it's consumed as a service, we use this automation framework to be able to continuously add new features and functionality into this particular solution. So if I come up with a new feature tomorrow, you automatically have access to it, similar to what the Meraki guys enjoy today. We also have web-based portal for access, simple things we can do, or we can actually do an API-based access. And we're extending that to other management platforms like DNAC and Meraki-based dashboards. It is operated by Cisco. So Cisco behind the scene is providing 24/7 by 365 support. Not call Cisco when something goes wrong. No, we're actively monitoring your network. We're actively making sure that the network is adhering to the KPIs and the KSOs that you actually have associated with it from a service standpoint. We're actually also focused on seamless software upgrade and firmware upgrade of the edges themselves. As software matures and progresses, we do have to upgrade the systems. And we want to make sure that we have a methodology that allows for this system to be upgraded without having a forklift upgrade process into place there. And last but not least, SIMs. Order the SIMs through Cisco, you get the SIMs delivered, you manage the SIMs, you activate and you deploy them in the devices themselves. And then last but not least, which I'm going to be focused on, is how you do this policy integration and security integration that really leverages on the capabilities of an existing ISIT deployment that you may already have in your existing mining operations for Wi-Fi based networks. So we're really, in the roadmap, really going ahead. We're really pushing ahead. So we've got ICE integration in the fall. We're doing umbrella integration now. The next piece is SIG integration, which is an approach whereby we're going to really leverage on the capabilities to focus on supporting clean traffic to and from specific enterprise customers, where that ecosystem becomes very important because we want to ensure that we validate these mining specific applications that within this particular framework, so that these things are automatically picked up by the security architecture of the solution itself. So, ICE. For mining operators, ICE is the predominant platform that is currently being used to manage endpoints, whether it's a Wi-Fi endpoint or a wireless endpoint. In some cases, I've seen ICE being used to manage things as well, so sensors and other non-human access-based systems themselves. We also see ICE being used for a lot of policy decisions when it comes to network devices, switches, wireless controllers, and VPNs. And ICE acts as a bridge to integrate a lot of identity services that enterprise customers like miners actually have. So LDAP access to all sorts of interesting systems, whether or not Azure or you have an Active Directory system that you want to integrate with this particular authentication scheme or authorization scheme makes no sense. Multi-factor authentication, SAML access, all these types of capabilities, ICE acts as a bridge between the systems that are on the back end from an OSS, BSS, and how the devices and necessarily the people behind those devices get access to them. ICE also drives through a lot of mechanisms, cloud and analytics, as well as being able to assist with security when it comes to umbrella integration, specific on the firewall side, because SGGs can be set by ICE. And of course, we have a rich ecosystem of partners that use ICE as a foundational element to deliver their sets of services going forward. In this picture, we're now delivering private 5G. We want to make private 5G as easy and as simple to onboard on an ICE server going forward, even though we're delivering it mostly to a cloud-based infrastructure where there's components on the local side. It should not matter. The benefits of this is that whatever the ISIT organization in a mining operation is doing today to manage policy, to manage micro-segmentation, to manage SGTs that you apply to applications, Should not matter whether the device connects via Wi-Fi or via private wireless network services. And that's the intent we wanted to do. Easy integration. It's basically all the existing policies, you just reapply to that, and it makes the handover between Wi-Fi and private wireless networking simple because it's the same device. The same policies should apply, even though it's gaining access via private wireless infrastructure versus Wi-Fi. A brief slide on why this is not easy is because in the licensed radio world, specifically in the 5G licensed radio world, most of authentication service is driven by a SIM, that piece of card that comes off of the back of this envelope here itself. And that gets stuck inside of a device. If you think about it, in the Wi-Fi world, we don't do that. We actually have username, password, we use certificates or whatever from an authentication standpoint, but we never use a physical entity that you stick in the device. So obviously you have two different authentication domains to deal with. On top of that, 5G does a lot of obfuscation of the IMSI, which is the entity that really drives the authentication process itself, by doing concealed ID hiding. So you need to be able to support this from a technology standpoint, even though your device authentication parameters might be stored somewhere in the open. So we have to bridge the gap between these two worlds in terms of how we do it simply in the 4G space and how a more complex authentication mechanism in the 5G space based on this SUPI type model for SIMs is handled for these types of devices going forward. Let's be honest. If you have a robotic system, if you have an autonomous hauler, you do not expect a user to go to that device and type in a username and password. That's not going to work. So it has to be plug and play, plug it into the device, and we should be able to authenticate that device and pass authorization requests to the ICE server so that we can actually do microsegmentation, drop it off in the right VLANs, give it the right IP address, give it the right SGT so that your firewalls and all the other systems upstream know, hey, this is an autonomous haulage system. We need to make sure that the microsegmentation VLANs construct that we created behind the packet core delivers this in a most efficient way to the controller so that controller can control the device itself directly without having to deal with, oh, there's two-factor authentication in its way, and it's coming from the outside network, and I have to establish a VPN connection and all that jazz. No, it needs to be simple, straightforward, plug and play, while providing the highest level of security and validation of the policy associated with that. In addition, there's
Derick.
Go ahead.
Yeah, just before you move on to that slide, in the previous slide, you talked about eSIMs being on the roadmap. Troy was just asking kind of where that's at, how far out. Do you have any commentary on that?
Yeah, Cisco is actively participating in the eSIM world. In fact, on our IoT side of the business, we've already made available eSIM capabilities in our IoT functionality. You will see eSIM being offered as part of the private 5G as a service offering. Most, if I don't want to misspeak myself, I believe it's in the fall timeframe for this year. So what we're doing is we're leveraging what we've already done on the IoT side and just bringing it forward to the private 5G as a service side. It does require cooperation of the devices themselves, because certain devices, when they actually support eSIM, they have to do a certain, manufacturing-based validation of the eSIM with the vendor, which is Cisco in that case. And that's the part that we're currently focused on so that we can make that simple, so that when a mining operation orders a Caterpillar device with an eSIM-based capability inside of it, they don't have to do anything special just to be able to register that eSIM and be able to get that functionality going forward. But yeah, that will basically mitigate the, I got to stick this, SIM in the device somewhere.
Yeah, thanks a lot. We've got about 5 or 10 minutes here before we want to get into the close. 10's probably okay too, but just give you a little time check there.
Thanks, Roland. I'll take 15. So, QoS. One key point to discuss on the licensed radio or licensed private wireless network services is QoS. There is a strong QoS framework that is, been around for years and years in the licensed radio world, and we would love to take that side, which is the left side of the slide, which is how we do QoS on our private layer systems, and tie it to how you do QoS on your IP-based infrastructure from an ISIT standpoint, to really drive the point that would it be nice if ICE could actually drive that QoS mechanism. So if it's an autonomous haulage vehicle that connects into it, I authenticate that through the 3GPP standards. I authorize that autonomous haulage vehicle to say, okay, mister, I want to give you QoS flow QFI1, which is then tied into my diffserv core point or TOS-based QoS mechanisms I do on the IT side. So I can provide the linkage and the bridge between the two infrastructures. Again, we're dealing with a chain of things that provides connectivity, and what we're building is a mission-critical, assured infrastructure that needs to have this decided on from an engineering standpoint, so we don't run into issues when guy that's surfing onto YouTube watching the latest Beyonce video, causing your autonomous haulage vehicle to disconnect because it doesn't get enough bandwidth. It is that detailed engineering that we're focused on, laser sharp focused on, to provide that capabilities and linkages from it. But even further, you as an operator, you as the IT person can drive it now dynamically to the authorization profile that ICE brings. Again, if you're interested in reading it, how we do this ICE integration, it's based on TS29.61, which is, if you're familiar with licensed radio, it's the 3GPP specification. So if you type in that 3GPP TS29.061 in your Google browser, you'll get a new world that pops up. And it talks about how these types of systems are supposed to interact with non-licensed radio systems and provide secondary authorization, IP address allocation. How do we set bit rates on a per device basis? And how do we provide a QoS policy reference that we can tie together these two systems? That's what we've implemented. If you're interested in terms of the standards, it's not some magic thing that Cisco invented. We're just following the standards and making sure that it becomes relevant for operations to go forward with. So I put in a couple of slides since I'm running out a bit of time here. I'll leave this up for people to enjoy maybe afterwards if you're really interested. But effectively, ICE sits in the middle. ICE is controlled by the operator like yourself. We basically onboard the ICE server, and then any SIM that is delivered and connected into your systems gets registered in the control center from Cisco, but then we have a mechanism whereby one intends to authenticate and wants to authorize. We initially authenticate and authorize using the private wireless networking framework, but then afterwards we talk to the ICE and say, hey, we have this device, we have authenticated. What would you like me to do with it? What VLAN? What IP address? What QoS? What SGT do you want me to assign with this? So you as the IT person can now drive and be in control of that environment going forward, in addition to being in control of the SIM that actually gets registered for the service. And same thing with the user planes. Once you have authenticated the device can open up multiple sessions, what we call PDUs. We re-authenticate, authorize each session so that you can say, if it's a YouTube video stream coming from that device, okay, I'll put it in the lowest class. If it's a command and control, an Emerson Delta V flow that's coming from the device, I want to be able to put it at the highest priority and put it on a protect channel because that's how the Emerson Delta V framework is supposed to be built. And it is as simple as going into our portal. I'm showing you a little portal view here, whereby once you've created your account, once you've added yourself as the admin, it then will ask, hey, what is the ICE instance or multiple ICE instances that we need to connect into? You need to specify the admin and password for the ICE instance. You need to specify the radius authentication port, as well as the shared secret. And we will automatically communicate with the ICE server then to be able to fetch policy mechanisms, fetch policy profile settings for the individual end devices that we have out there. So, last slide. What and why is this important? Again, it is all about control. It is all about the ability to offer an operator, a mining operator, ISIT person, the ability to say, I can provide consistent policy and authorization across all my access type, whether it's wired, Wi-Fi, curb, and now private 5G. It's all the same. I can do my authorization on a per device basis, regardless of how they access in the infrastructure.
Did we lose audio? Yeah, we lost Derick's audio. There we go.
Sorry, yeah, there's a call coming in.
Yeah, there we go. We're back.
Yeah, there's a call coming in. Apologies for that. So yeah, we can control the policy. We can control the security framework. We can do micro segmentation. Which VLAN does this guy belong into? We can set the SGT so that your downstream firewalls and any policy engines can take advantage of that. And we can do this on a PDU by PDU basis, not only on the device, but we can even control the individual applications. So you have that fine-grained control for a private wireless infrastructure on your site, same way as you would have for any other services that provides that capability. And so it is what we think a fundamental capabilities of this private wireless networking services that Cisco is proud to offer for our customers, that a lot of customers have already looked at this and have run this in their proof of concept are quite excited about, because it gives you the capability from a control standpoint.
Hope you enjoyed this presentation from Derick. For more information on Cisco and the mining industry, check out cisco.com/go/mining. Take care.